here today to do noise measurements on the Augusta-Westland 109, the A109. These noise measurements will be used to generate hemispheres, which will be part of the rotorcraft modeling tool NORAH. NORAH stands for Noise of Rotorcraft Assessed by a Hemisphere Approach, and is a software tool of a novel rotorcraft modeling methodology which was developed by EASA and the European Committee. In the current project, we are extending this methodology, developing a rotorcraft so the noise modeling methodology really takes a step forward in terms of aircraft noise modeling. Obviously for rotorcraft noise, because currently there is no standard or no guidance on that, but also in the approach taken. This method employs an approach where we model the source characteristics, and the propagation modeling, we do that separately. And the source is modeled by so-called hemispheres, in which you store the emission characteristics of a vehicle, a rotorcraft, a helicopter, or for example a drone. And the noise propagation is done by semi-analytical modeling. This is an incredibly versatile methodology which retains spectral information, which helps us to also prepare the model for future needs. A clear-cut example of that is, for example, the modeling of drone noise in an urban environment, which is currently not catered or not incorporated in NORAH yet, but it's very easy to do so.
We started the NORAH project with the European Commission in 2015. We realized then that there was a lack of robust data and prediction tools to quantify the noise of helicopters. Indeed, as part of the Environmental Noise Directive, member states have a mandate to quantify and report the noise of various transport modes on a regular basis. And noise is generally reported in the form of noise maps, which indicate where noise is located and how intense it is. This is the first step to identify where noise mitigation actions need to be taken. There is already a wide range of tools to quantify the noise of cars, trains and aeroplanes, but tools for rotorcraft are still lagging behind. The NORAH project was therefore kicked off to fill this specific gap. In a nutshell, the NORAH project will deliver a detailed methodology and noise datasets to quantify rotorcraft noise, with a focus on helicopter types that are most often used in Europe. We will make this information available on the EASA website. In addition, we are working on a noise prediction software which anyone can use if they do not want to develop their own model. With that, we hope that member states and local authorities can better assess the local situation with regards to helicopter noise and answer questions such as: how does helicopter noise compare to that of other noise sources? Is helicopter noise increasing or decreasing over the years? Do our noise mitigation actions bring concrete results? We do expect that the NORAH noise prediction methodology and datasets will continue to evolve after the end of the project in 2024. The scope of helicopter types covered will keep on being expanded so that it covers a larger share of the European fleet. But also, the NORAH methodology can be used to predict the noise of drones and air taxis. And we know from various surveys that noise is a concern for European citizens when talking about these emerging markets. So we are already developing dedicated noise datasets so that local authorities who plan to allow operations by drones or air taxis can predict the noise they will generate. We therefore encourage everyone interested in this noise modeling capability to visit the EASA website and find out more about the latest developments and available datasets for NORAH.